The next shape that we have says that it's equilateral, and we have 1, 2, 3, 4, 5, 6 sides. So this is actually an equilateral hexagon. And what you'll learn, another term that you'll learn in geometry class, is if a shape is equilateral and equiangular, which means that the angles are congruent, then it's called a regular hexagon. So in this equilateral or regular hexagon, each side is 10 millimeters long. And something neat that happens with hexagons is if you divide it up, it actually ends up getting divided into 6 equilateral triangles. So finding the area of a hexagon is just a little bit more complicated than finding the area of a triangle. Finding the perimeter of a hexagon, if you know that it's equilateral, is actually pretty simple, because I know that all 6 sides are 10 units long. So 10 times 6 is 60 units long for the perimeter. 60 millimeters. That didn't end up taking very much work at all. If I want to find the area, though, the area is a little bit more complicated. I'm going to take just one of these individual triangles. I'm going to drop the height. I told you that it's equilateral, so that would mean that all of the sides are 10 units long. But I'm going to split this base into 5 and 5. Then I can do Pythagorean theorem to find the height. X squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. So when I take away 25 from both sides, I get x squared equals 75. 75 is not a nice perfect square, but hopefully you've learned a little bit about simplifying radicals. And the biggest perfect square that goes into 75 evenly is 25. So I'm going to break up this 75 into root 25 times root 3. Square root of 25 is perfect, so I can take the square root of 25 because 25 is a perfect square. It's 5. And then square root of 3 is messy, so I'm going to leave it root 3. So now when I go to find the area of one of these triangles, I have a base of 10 and a height of 5 root 3. So I'm going to erase some of this so I can leave myself some room. All right, so I've got 10 for my base, I've got 5 root 3 for my height. So the area is, there's 6 of them, so I'm going to do 6 times 1/2 base, which is 10, and the height, which is 5 root 3. So 6 times half times 10 times 5 root 3, which ends up equaling 150 root 3 millimeters squared. Our final problem is another trapezoid problem, which we've already looked at before, but this one's a little bit different because this time we gave you the area, and what we're asking for is how long the larger base must be. So we have a height of 8 millimeters. The smaller base is 10 millimeters, and then I'm going to call the larger base x. And remember that the formula was area equals base 1, which is 10, plus base 2, which is x, over 2, because we're finding the average of the two bases, times the height, which is 8. And if we know that the area is 128, I'm going to substitute that in. So I think that the next thing that I'm going to do is to distribute this 8 to the numerator of the fraction. So I have 128 equals 8 times 10 is 80. 8 times x is 8x over 2. Then I'm going to simplify the 80 plus 8x over 2 and say 128 equals 80 divided by 2 is 40, plus 8 divided by 2 is 4x. Then I just have a quick equation to solve. I'm going to take away 40 from both sides, and I get 88 equals 4x, and 88 divided by 4 is 22. So the length of the larger base of this trapezoid would be 22 millimeters long. So just to get a quick summary, what you should leave this opener with is a few formulas that you can use to find areas of different figures. Perimeter is really just the distance around a figure, so there aren't too many formulas for that you need to know. But some really good area formulas that would be very useful for you to know would be the area of a rectangle, which is length times width. Area of a triangle, which is 1/2 base times height. Area of a circle is pi r squared. And the area of a trapezoid, which is the average of the bases times the height.